Hi. Hi. Today we shall be developing unit root test using augmented decay fuller, which is known as a ADF method. That means today we shall be developing unit root test using augmented decay fuller method. And here what is happening in case of decay fuller test, there may create a problem of autocorrelation, and to tackle autocorrelation problem, decay fuller have developed a test called augmented decay fuller test. And we have three decay fuller model here. You can see from here. First model is this is the first model, and this model has only intercept, and the second decay fuller model has only trend and intercept, and the third decay fuller model has no trend and no intercept. So there are three decay fuller model, and we want to check whether our variable y has unit root or not. That we want to check. And all the three model come to same decision all the time, whether our variable y has unit root or not. That means all the three model must comply that our variable, which is y here, has unit root or not. Okay, so to check it, to test it, we have set the hypothesis, and here is a null hypothesis. Variable is not stationary or got unit root, meaning that our variable y is not stationary or got unit root. An alternative hypothesis is that the variable y is stationary or does not have unit root. So that is alternative hypothesis. Okay. So, and normally what happens, to make the variable stationary, we should go for first differencing method. Normally it happens when we convert a variable into first difference, then that particular variable becomes stationary. That normally happens, but not always. Okay. Now we see our data. The data is here. This is our data file, and you can see the year, right, from 1970 until 1995. We have the yearly data and y. Y is the variable from 1970 until 1995, and and we want to check whether this y variable has got unit root or not. That we want to check today. And what I have done also, I have converted this y variable into first difference, and that is called dy. Okay, what I have done here, the first row I have kept blank. So I start from the second row. Okay, how to get this minus 3? 2 minus 5, I can get minus 3. How to get this 4? 6 minus 2, I can get 4. How to get minus 5? 1 minus 6 is minus 5. So in this way I have got all the digit, all the numbers, and what I want to do, I shall be also checking whether this dy variable has got unit root or not. That I shall be also checking whether the first difference of y has unit root or not. Okay, so we can check now using statistics. Okay, so I go to statistics then. Okay, I go to statistics. Here is the statistics. I click on the statistics. Then I click on the time series. Then click on the test. Then click on the augmented Dickey-Fuller unit root test. I click on it. And here are the data, year, y and dy. So first I choose y, that is our variable, and time settings, here is time settings, and in the time settings I put year, then here I choose yearly because our data is yearly data. Then I press OK. Okay, and then out of these 4 box I choose the first one. Sorry, I choose this one, display regression table. So that I choose, meaning that Dickey-Fuller model. Okay, and we have 3 Dickey-Fuller model. So and I showed it last time. Those 3 are like this. The first one is Intercept, right? And the second one is Trend and Intercept. And the third one is No Trend and Intercept. That we have already seen. Okay, so what I shall do now, here the first I shall be checking with the intercept only. Then gradually I shall check this one, and then I shall check no trend and no intercept. Right? Okay. So first I start with intercept only, whether our variable y has unit root or not. Okay, and here what I am doing, here you say, here I keep all the three blank because my target to check only intercept. The model having only intercept, so I keep all three blank, and here I choose lag difference 0. Here I choose lag difference 0. Then I run the model. Okay, everything is set. We can run the model. So I press OK. So the outcome is coming up. I think the outcome has come already. Here is the outcome, you can see. Here is the outcome. And you see the lag is 0, right? And this is our outcome. And from data from 1970 to 1995, right? This our data has come up. Okay, and you see the Dickey-Fuller test, right? Dickey-Fuller test for unit root. And here is test statistics. You can see the test statistics. 1% critical value, 5% critical value, 10% critical value. But normally we choose 5% critical value. That is the normal guideline. 5% critical value we choose. Okay, and then another guideline that when the test statistics, when the absolute value of test statistics is more than critical value, we can reject null hypothesis and can accept alternative hypothesis. But if the absolute test statistics is less than critical value, then we cannot reject null hypothesis. Rather, we accept null hypothesis. That is the always guideline. Okay. And what is our null hypothesis? Null is y has unit root or not stationary, right? That we have already seen, right? And what is sorry, I've done mistake. What is null? Null is that we have already seen actually. Null we have already seen. I can show you again. Null is y has unit root or not stationary. And what is alternative? Alternative hypothesis y is stationary or does not have unit root, right? That is alternative hypothesis. What is null? Y has unit root or not stationary. And what is alternative? Y is stationary or does not have unit root. Okay. And here what is happening? Okay, when I say absolute value, that means there is no minus sign. That means the value is 2.826. And here is also absolute value, meaning that 3, not minus 3. So 2.82 is smaller than 3. So we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that y has unit root, or y, the variable y is not stationary. But here one thing we have to make sure that so actually uh, this one is our first model, right? First Dickey-Fuller model, and which has only intercept. You can see from here it has only intercept. So that is the first model of Dickey-Fuller test. But make sure here this L1 must be negative sign. Make sure it must have negative coefficient, right? Otherwise the model is not valid. The model is not valid if the coefficient is not negative. So here it is negative, so we can accept this model. And here what is our decision? Y has unit root. Okay, now we check our second model of Dickey-Fuller test having trend and intercept. Okay, so I go to statistics as before, then I go to time series and test and augmented Dickey-Fuller unit root test as before, right? Then I click on it. Okay, so here we have trend and intercept. So what I do, I choose this one, include trend term in regression, right? Meaning that this model will have trend and intercept, and I keep here lag difference as 0. Okay, so now I click on the OK. The result has come up, right? So here is the result. The lag is 0, right? That we set, and this one is the test statistics, right? And this is the 5% critical value, and here you can see that 3.21 absolute value, 3.21 is smaller than 3.6. So we cannot reject null hypothesis. Rather, we accept null hypothesis. And so, meaning that y has unit root, because we cannot reject null hypothesis. Okay. And the second one, I click on the more, right, to check our model. This one is a model, right? This one is a model, and this model has trend and intercept, right? This model has trend and intercept, but make sure the L1, the coefficient of L1 must be negative, right? And it is negative. So we can accept the model. Okay. So here, what is our decision? Y variable has unit root. Okay. Now we check our third model of Dickey-Fuller. The third model has neither intercept nor trend, right? Okay, how to check it? I go to statistics as before, then I go to time series as before, then I go to test as before, then I go to augmented Dickey-Fuller test as before, then I click it. Okay, here what I do, I click on the suppress constant term. So meaning that in this model there will be no intercept and no trend, right? And I keep lag value 0. So everything is set. I click on the OK. So this is the outcome. This is the result of the Dickey-Fuller test having no intercept and no trend. And you can see, okay, here our test statistics absolute value is 1.55, which is less than 1.95, meaning that we can reject, meaning that we cannot reject null hypothesis, meaning that we accept null hypothesis. And what is our null hypothesis? Y has unit root. So variable y has unit root. And this one is our third model of the Dickey-Fuller test. And here you can see this model has no trend, no intercept. But make sure this coefficient of this L1 should be right negative, and it is negative here, right? So the model is valid. Okay, so what we have done here, we have checked 3 Dickey-Fuller model. The first model had only intercept, and the second model has intercept and trend, and the third model has no trend and no intercept. And all models are telling the same thing, that y variable has unit root. So meaning that our variable has unit root, or the variable is not stationary. So that is our decision from this from this testing. Okay, and so so that is our decision from this testing. Thank you very much for being with me for a while.